So today we're going to continue with our learning of trig. We're going to take what we learned in section 8.4 on trigonometry with sine, cosine, tangent, and inverse sine, cosine, and tangent, and apply that to something called angle of elevation and depression. So if you have not watched the 8.4 video or learned the 8.4 notes over trig in class, you will need to make sure you do that before you try these problems, because these problems will not make sense to you if you haven't first learned trig. Okay, so in section 8.5, the angle of elevation and depression is a specific type of angle that you're going to use to draw your own pictures and then solve using the trig that you learned last class. So this picture kind of puts together what they are. So an angle of elevation is an angle that is formed, and it's going to have a horizontal line, so it's going to have a line straight out. And then it's also going to be, with the horizontal line, it's going to use the observer's line of sight to an object above the horizontal line. So that sounds kind of technical, but let me show you in the picture what that looks like. So the angle of elevation, picture this guy, this is like a football stadium, it's kind of blurry, but he's standing on the field and he spots somebody up in the stands. So normally if he's looking straight out, here's his horizontal line of sight, but then as he tilts his head up, he looks to this guy in the stands, and that creates this angle of elevation. So angle of elevation needs to be an angle that is straight out, there's a horizontal line, and then another ray goes up, so basically up from that horizontal line. So this is called elevation, okay? Which makes sense because elevate means up. Okay, so for depression, depression is the opposite of that. So depression is an angle that's formed still by a horizontal line, but then the observer's line of sight will go down below to the person below. So if you look at the guy up in the stands, if he looked straight out, that would be the horizontal line, but as he tilts his head down to look at the guy on the field, that creates an angle of depression, and down means depression. So the angle of depression would be here. So this guy would be up here looking straight out, and then he would tilt his head down, and that creates an angle of depression. All right, now the thing that you want to know about depression and elevation is they create this like rectangular figure together, and so they're pretty much connected. It says horizontal lines are parallel, so these lines would be parallel. So the angle of elevation and depression, you might recognize that as alternate interior angles. They are AIAs, and because they are AIAs, they're going to be congruent to each other because of the AIA theorem from chapter 3. So here's the point. If you have an angle of depression, you can change it to elevation, and if you have an angle of elevation, you can change it to depression because they are considered alternate interior angles. So if my problem mentions depression, feel free to use elevation because they're alternate interiors. Or if my problem mentions elevation and you have depression in your picture, feel free to use that. What I want to show you over here is what most kids do at least one time when they're learning this. A lot of kids will say that they think that this is depression. And so I want to put this out to the side, and I want you to draw this because that is not depression. Depression in this picture would be out, straight out, horizontal, and down. So this is depression, and then this is elevation. But this angle right here is nothing. So that is a no-no. Don't put it there because you'll miss the problem every time. All right, so what's going to be new in this section besides angle of depression and elevation is taking those two angles and drawing your own picture and then solving with trig, which we learned last section. So let me show you how you do this. So you first read the question and then make your picture. It's going to be a right triangle, and we're going to put it down here. So it says, Leah wants to see a castle in an amusement park. She sights the top of the castle at an angle of elevation of 38. Okay, so what I'm going to do is I'm going to make an angle of elevation and go ahead and go straight out, horizontal, and then remember out and up. So this is 38 degrees. All right, she knows that the castle is 190 feet tall. So the castle is going to be over here. Now, there's a reason why I'm a math teacher, and that's because my drawings are awful, but that's okay. At least you're watching the video and not seeing it in person. So there's my castle, and she's looking at the castle that is 190 feet tall. Leah herself is 5.5 feet tall, and we're going to assume that means up to her eyes. That's how tall she is to her eyes. So this is Leah looking to the castle, and there is her eyesight. So this part of her body is 5.5 feet, okay? So I guess I need the castle. Bear with me for a second. The door needs to be down on the ground, which would make more sense. We'll make that a window. There's your door. Okay, so this entire thing is 190 feet. But remember that Leah is 5.5 feet up to her eyes. So in this problem, which is kind of weird, we're going to need to do some subtraction. So keep that in mind. So let's see what they're asking us to find. How far is she from the castle? Okay, so I'm going to put an X here on this bottom distance because that's the distance we're trying to find, the distance from her to the castle. All right, what I was getting at is in order to find this X, we need to compare it with this side so that we create this right triangle here. This is considered a right angle. Now, we can't use 190. We're going to need to minus the 5.5 feet because we got to take off from her eyes down to her feet. This is the only problem you'll have to do that on. There may be one in the homework like this. Normally, you won't have to do this, but you do on this problem. So we need to make this height instead 184.5 feet to account for that distance from the ground to her eyes. All right, so in this picture, if you look, and if I just kind of sketch and take out all the other stuff in the picture, this is 184.5, this is X, and the angle of elevation is 38. So we're going to look at what trig ratio to use. So this goes to last section. So this is opposite, and this is adjacent, and this is hypotenuse. So we need to use tangent. So we're going to do tan 38 equals, and it has to be over A, so it's 184.5 over X. Now, if you watched the last video or were in class and learned this, then this will seem familiar to you. You're going to put this over 1, make a proportion, and we're going to cross multiply. Okay, so I'm going to solve this one out, and then in the other ones, I won't take the time to solve them all out because you'll know that from last section. Make sure that your calculator is in degrees, and you're going to hit tan of 38, and you're going to round to 4 decimals. And the reason why, again, we round to 4 decimals is all of these trig ratios are really close together. So we're going to do 0.7813. So this is going to be 0.7813 x, because I'm going to cross multiply that, equals 184.5. And then I'm going to divide by that 0.7813. So I'm going to do 184.5 divided by 0.7813. And I'm going to get a distance of 236.1 feet. So X is 236.1 feet. And that's the distance from Leah to the castle. Now, because you've already learned section 8.4, I want to show you how you can type this in quickly, a little bit easier than what you did here. If you notice when you cross multiply, you are always taking this number divided by this if X is on the bottom. So if your variable's on the bottom, you're taking 184.5 divided by tan 38. So I could actually skip a step on the calculator and do 184.5 divided by tan 38. And that's going to give me the answer in a little bit faster time than actually writing out the 4 decimals. What it does is it just allows the calculator to take that value and go ahead and put it in for you. So if you like that method and want to save a little time, feel free to do that. Okay, let's go to example 2. We're going to sketch a picture. It says, from a lighthouse, the angle of depression. Okay, so you're going to love my lighthouse. Again, I am money when it comes to drawing. Not really. So there's my lighthouse. Okay, the angle of depression is 25 degrees. So there is a dude standing at the top of this lighthouse. And the angle of depression, remember, is straight out, the line of sight that goes out, and down. So there's my depression angle. Now I'm going to close this up and make myself a right triangle. Now it says the angle of depression is 25 degrees. So I'm going to put a 25 degrees on the depression. Not here, remember, it's here. If the lighthouse is 105 feet tall, now when I come over here and I put 105 feet right there, that's not in my triangle. So think back to this rectangle. In a rectangle, opposite sides are congruent, which is what we have. So we're going to take that idea and we're just going to transfer that 105 feet to this side because we know that piece of the rectangle has to match that piece. And then it says, how far away is the boat from the base of the lighthouse? Okay, so this is my boat over here. So there we go. There's the boat. How far is it away from the base of the lighthouse? So right here is my X. That's what I want to find. Well, that's not in my triangle, so I'm going to move that using the rectangle to the top and make the X up there. Here's another option. If you don't like that, then what you could do is you could change depression to elevation because depression and elevation are alternate interior angles. So feel free to use this triangle right here instead. You'll still have your X and you'll still have your 105. basically, when you look at this rectangle, these two triangles match. So it doesn't matter if you use depression or elevation because they're alternate interior angles. Just don't use that angle or this angle because those are not depression or elevation. All right, so looking at this is going to be opposite and adjacent, O and A. So I'm going to run through this pretty fast because you already know this. So O and A, again, is tangent. So tan of 25 equals, this time it's going to be 105 over x. So I'm going to take the tan of 25 and put it over 1. I'm going to cross multiply. Tan 25x equals 105. And then I'm going to show you that shortcut that I showed you where you don't actually have to type in or get the 4 little digits. You can let your calculator do it for you by doing 105 divided by tan 25. The calculator already knows those 4 digits for the tan of 25, so it's 225.2. So x is 225.2, and then you want to use the units of feet on this. That's the distance from the base of the lighthouse to the boat, or you can represent it up here in the rectangle. All right, example 3. A search and rescue team is airlifting people from the scene of a boating accident, and they observe another person in need of help. Okay, so if the angle of depression, so we have depression again, so I'm going to start by making an angle of depression, which is out. Remember the horizontal out and down. This is depression, and it is 42 degrees. Do not put it here. And then I'm going to go ahead and close and make my right triangle. And so this is 42 degrees from the helicopter. So this is a helicopter. Oh my. Okay. Whatever. That's the helicopter. And the helicopter is 18 feet above the water. Okay, well, if you look at my picture, this is my helicopter and this is the water down here. That is 18 feet. But the problem is that's not my triangle, so I'm going to use my rectangle and bring the 18 feet over here. I'm also going to close this and show you how you could use the bottom. All right. It also says it wants the horizontal distance from the rescuers to the person. So this is your horizontal distance, that's the horizon. So this is x. It's also down here. So the point is, if you want to use this top triangle and use depression, you can. Or since depression and elevation are alternate interior angles, you can change it to down here. So you're welcome to either use this triangle or you can use this triangle. It doesn't matter. It's going to be the same trig ratio. So you go from the 42, and this is opposite and adjacent. You're going to notice a lot of the word problems are tangent. It's just because of what they're having in the picture. It's usually a tangent ratio, but it's not always. So tan of 42 equals 18 over x. So you're going to put this over 1. You're going to cross multiply. You're going to end up taking 18 divided by tan 42. So if you want to use that shortcut, you can, or if you want to solve it like you did last class, feel free to do it that way too. So this is going to be 19 point, well, if we round to the nearest tenth, it's going to be about 20.0. So x is about 20 feet. And that is the horizontal distance from the helicopter to the person. It's represented 2 different ways in the rectangle. Okay, one more example. We are not doing example 5 or the U-try. You will actually cover those in pre-calculus, and with short time this year, we'll just be covering example 4. Okay, so Kendall is watching a space shuttle 6 miles from Cape Canaveral, Florida. So I'm going to put Kendall here, and she's watching from Cape Canaveral is 6 miles to the shuttle launch. When the angle of elevation from her viewing point is 80 degrees, so you've got this shuttle that's going to be going straight up. Her angle of elevation, so that is the horizontal line out along with the line of sight when she tilts her head up, that is 80 degrees. It says how high is the shuttle? So we're going to put an X here. So for this one, since it's not depression, I really don't need to use that top triangle. I'm just going to use this bottom one. And so we're going to go O and A, and again, this is tangent. So tan of 80 equals, opposite is X, adjacent is 6. Now this we're going to put over 1. We're going to cross multiply. The short way of cross multiplying this is you can literally take the tangent of 80 times 6. You don't even have to get the 4-digit number if you want to do a shortcut. Tangent of 80, you just need to make sure you close the parenthesis and then times 6, and you'll get 34, about 34. So X is going to be 34, and this is in miles because it's a shuttle, so it's really high up. And that is the answer for that question. So keep in mind, if you don't want to use the 4-digit numbers, the calculator has them stored in there. You're just taking out that part of the solving and allowing the calculator to put it in for you.